Have you ever looked at a giant mountain range or a deep canyon or even just the hill down the street and really wondered, how did that get here? Well, it turns out our planet's surface is basically a battlefield. It's the site of a constant epic tug of war between forces that built things up and forces that tear them right back down. Today, we're going to get into how our world really gets its shape.
So let's just start with this really basic question. If gravity is always pulling everything toward the center, why isn't the Earth just a perfect, smooth ball, maybe covered completely by water? What's stopping it from being totally flat? Well, the answer is that planetary tug of war.
I want you to imagine two huge cosmic teams. On one side, you've got forces pushing up from inside the Earth, and they're responsible for making mountains, creating continents, and on the other side, you've got forces on the surface. Think sun, wind, rain, working 24/7 to grind everything back down to sea level. This fight, this conflict, is what carves out every single landscape we see.
So let's meet the teams, shall we? First up, powered by the crazy amount of heat in the planet's core, are the endogenic forces. Let's call them the builders. Their entire job is to create topography, to push the Earth's crust upwards. And their opponents? The exogenic forces, who we'll call the sculptors. These guys are powered by the sun and work from the outside in, trying to wear it all away.
All right, let's dive in with Team Builder first. These are the endogenic processes. They are the architects of our world's grandest features. And what's wild is that they operate on two totally different timescales. Unbelievably slow, and then shockingly fast. The slow and steady player on the team is something called diastrophism. Now, this is the process of the Earth's crust bending, folding, and breaking over enormous spans of time. We're talking millions upon millions of years. You can't see it happening, but the results? They're literally the biggest things on the planet.
And this slow burn process has two main moves. First, you've got orogenic processes. That comes from the Greek oros, for mountain. These are horizontal forces that literally squeeze the crust together to create massive mountain ranges. Then you have epigenic processes. Epiros, meaning continent, which are these huge, slow vertical movements that lift or drop entire chunks of continents.
But the builders also have a rapid response team, sudden forces. These are the dramatic events you see on the news. Earthquakes that can rip the ground open, and volcanoes that erupt with just incredible power, creating huge changes in a matter of hours or even days. Now, it's pretty easy to think of something like a volcanic eruption as just destructive, right? But from a geological point of view, it's actually a constructive force. This is the builder's express lane for creating new land, adding new material right to the surface, building volcanic mountains, and forming these huge lava plateaus you see in places like India. So the builders are busy creating this rugged, lumpy planet. But they don't get to work unchallenged. Now we have to meet the other side of this tug of war, the sculptors. These are the exogenic forces, and they're driven by the sun and gravity. Their one and only job is to wear away every single thing the builders created. This whole process is called denudation, which literally means to strip bare.
The sculptor's #1 tool is weathering. This is the all-important first step. It's the process of breaking down rock right where it sits, or in situ if you want to use the fancy geology term. It doesn't actually move the rock bits, it just turns big, solid rock into smaller, weaker pieces, getting it ready for transport.
And one of the most powerful forms of weathering is called frost wedging. It's a really simple idea, but it's relentless. First, a little bit of water seeps into a tiny crack in a rock. Then, overnight, that water freezes and expands. Finally, that expanding ice acts like a wedge, prying the rock apart from the inside out. You repeat that cycle over and over, and a tiny crack can literally split a mountain in two.
And the force we're talking about here is just incredible. When water freezes into ice, it expands by about 9%. Now, that might not sound like a lot, but that expansion generates enough pressure inside a rock's little cracks and pores to literally shatter it from within. It's this silent, invisible force that just breaks solid stone.
Of course, frost isn't the only tool in the sculptor's toolkit. You've got chemical weathering, which uses reactions to basically dissolve rock, kind of like how slightly acidic rainwater can just eat away at limestone.
There's biological weathering, which is life itself, like a tiny seed sprouting in a crack and its roots slowly forcing the rock open. And once weathering does its job, erosion takes the stage. That's just the transport of all that broken down material by wind, water, or ice.
So where can we actually see this epic tug-of-war in action? Well, everywhere. But the perfect place to look, the absolute best example, is one of the most common landforms on Earth, a simple hill slope. It's the main stage for this battle between building up and tearing down. If you look closely, a typical hill slope tells you the whole story. Right at the top, you usually get this rounded, convex shape. That's where weathering is most active. Below that, there's often a steep, rocky, free face, like a small cliff. Then you get a constant slope, which is kind of like a conveyor belt for moving all the debris down. And at the very bottom, you'll see a concave shape where all that weathered material finally comes to rest.
Okay, but why does the stuff on that slope sometimes stay put and other times just slide? It all comes down to this really critical idea in physics called the angle of repose. Basically, for any loose stuff, sand, gravel, soil, you name it, there's a maximum steepness it can handle before gravity just wins and the whole thing comes tumbling down.
Think of it like this. Imagine you have a brick on a wooden board. When the board is flat, the force holding the brick down is super strong. It's not going anywhere. But as you start to tilt the board up, the force pulling it down the slope, what scientists call shear force, gets stronger and stronger. And at that exact moment that the shear force becomes stronger than the force holding it in place, the slope fails. That's the tipping point for every single landslide.
Okay, so we've got this endless war between building and sculpting, and it's playing out on every single slope on the planet. But why does any of this matter to us? I mean, what's the actual result of this multi-million-year conflict?
Well, here's the kicker. The debris from this battle, all that stuff that gets weathered and eroded and moved around, it isn't waste. It's actually the very foundation of our world. All of that grinding and dissolving and transporting is what produces the sand for our beaches, the clay for our homes, and most importantly, the soil for our entire planet.
And just think about what that really means. This entire, massive process from a volcano building a mountain to a single drop of water freezing in a crack, it all leads to this. It creates soil, and without that incredibly thin, precious layer of weathered rock and organic matter, we couldn't grow food, period. So in the end, this constant planetary tug-of-war is literally what makes life on land possible for us.
Which kind of leaves us with one final big thought. We now understand the natural forces in this great battle. But today, in our modern world, humans have become a geological force all on our own. We move more rock and soil than all the rivers, glaciers, and winds on Earth combined. So the question is, in this great tug-of-war, which team are we on? Are we the new builders or are we the new sculptors?